All right, so the third part of chapter 8, Earth Systems, is about soils and mining. We learned a little bit about soils during our lab about soil texture. So first thing is a definition of soil. Soil is a mix of geologic and organic components. Organic decomposition from above combined with the geologic material from below, from the weathering of the parent material, forms that kind of mixture between the two forms what we call soil. Soil does a lot of things for us. It stimulates plant growth, breaks down organic materials, is a habitat for all different kinds of organisms, and also filters water. As we mentioned in lab, time is one of the most important ingredients in soil formation. As you can see, it starts with the parent rock and not that much organic matter on top. With young soil, organic matter starts to accumulate as plants and other organisms die, mixes with the geologic material. You can see the parent material starting to break down right here. If you look at this mature soil over here, we have greater nutrients, large trees can start to grow. We have a nice mixture of geologic and organic material. Other factors that affect the soil type would be parent material. So the different types of rock will give different chemical properties to different types of soil. Climate is another factor in soil formation. In warmer climates, we have more decomposition, whereas in colder climates, we have slow rates of decomposition that can greatly affect the type and the amount of organic material in the soil. Also, slope uh, affects soil formation as well. On steep slopes, the steeper the slope, the more the soil is subject to erosion. And then last but not least, different organisms in the soil decompose things at different rates. We'll talk more about that a little bit later. So if we look at the soil from parent material to organic material, we can look at what's called a soil profile. And a soil profile is divided into distinct horizons. Um, each horizon you need to know a little bit about. The O horizon is at the top and is just the organic matter, so no geologic material. So different stuff that's dying and decomposing. Right below it, we have a zone of organic material that has moved down, and also a mix of some of the parent material at the top. This is where most plant growth, most plant roots are found, and we call this the topsoil as well. Next, you have the B horizon, which is considered subsoil, and this has a mix of organic material and geologic material. Has more geologic material in it than the topsoil does. And this is also the place where we tend to find a lot of minerals that we like to mine, is in this B horizon. The C horizon is the least weathered portion of the soil profile. It's where the parent material is found. Almost no organic material, almost all geologic material. So just like we said before, organic material on top, geologic material at the bottom, then you have kind of mixing of those in between. Where you have kind of a healthy mix, we call it the topsoil. Where you have a little more geologic than organic, we call the subsoil, and then we have the parent material at the bottom. In some cases, you'll have an extra layer called the E horizon. It's the alluvial zone or the zone of leaching. Iron, aluminum, and dissolved organic acids are moved into the B horizon from this E horizon. We talked about another property of soil, which is its texture. Be sure to know how to use the soil texture triangle. If I were to put like a point somewhere on the soil texture triangle, you would go percent clay this way, percent silt this way, and percent sand this way to figure out what type of texture you have. Texture is important texture is made up of three different particle sizes, three different soil particle sizes. The largest size is sand. It's anywhere from this big to this big. And then silt is anywhere from this big to this big. And then clay is anything smaller than 0.002 millimeters, which is really, really tiny. If we think about how easily water flows through the soil, we can see that if it's mostly sand, an equal amount of water will flow through it. A large amount of water will flow through it relatively quickly. Silt, it might take 100 days for that amount of water to flow through, and then in clay, it might take 100 years. So just a little bit of clay can really affect the movement of water through soil. So what you want is a perfect mix. If we look back here, you can see that 40% silt, 40% sand, only 20% clay makes up the sort of perfect mix uh, for water permeability through the soil. This mix allows the water to move through the soil, not get waterlogged, but it also allows for enough retention of the water so that plant roots can absorb the water as well. So this is a perfect mix. Also, this is a good example of soil as a filter. For example, in Long Island, they have very sandy soil above their groundwater, which allows contaminated surface water to easily pass into the groundwater supply, and little filtration occurs. Whereas areas with clay, if you have a lot of clay soils, that can actually end up protecting the groundwater from pollution. And once we've realized this fact, we've actually started using clay to line our landfill so that when the various trash and garbage starts to decompose within a landfill, all of that polluted water from that decomposition process called leachate can't escape. Partly, first, we have some different kinds of man-made materials, but another material we use to prevent the leachate from going into groundwater is clay. We compact clay, and clay is one of the best natural ways to prevent polluted water from leaching into the groundwater down here. Soil also has a couple of chemical properties you need to be aware of. One is the cation exchange capacity, which is basically the idea that clay can hold on to essential soil nutrients for plants because they are negatively charged. Clay particles are negatively charged, and nutrients such as ammonium and potassium are positively charged. So the more clay you have, the more soil nutrients you can hold, and the better it is for plant growth. But there's a balance. If you have more than 20% clay, well, then water cannot flow through it very well, and soil can become waterlogged. And the reason why that's a problem is because plants have to perform cellular respiration as well, and they perform cellular respiration sometimes through their roots. And so if their roots are completely underwater, the plants can literally drown. So there's a trade-off between cation exchange capacity and porosity. So you need some clay, but not too much. Another chemical property of soil is base saturation. Basically, calcium, magnesium, potassium, and sodium are all bases that can neutralize soil acids, and for the most part, acidic soil does not promote plant growth. Every one of these, calcium, magnesium, potassium, can actually promote plant growth, except for sodium. Soils with a high base saturation and a high cation exchange capacity tend to support the most amount of plant growth. On the biological side, there's three groups of organisms that account for all soil organisms. This is fungi, bacteria, and protozoans, which are certain type of single-celled organisms. Animals such as earthworms and moles are present too, but not nearly as abundant as the bacteria, fungi, and protozoans. Most soil organisms are detritivores. If you remember back from chapter 3, I believe, that detritivores are organisms that consume dead plant and animal material, and they recycle nutrients inside the soil that makes them available for plant growth. Some soil bacteria, if you remember from the nitrogen cycle, some soil bacteria actually fix nitrogen, which is an essential process in getting nitrogen into plant tissue. Soil degradation is the loss of the ability of soil to promote plant growth, and this is something I found on the web. As you can see, that if a forest has a layer of organic material in topsoil, we convert it into pasture. After the pasture has been eaten away, if we don't conserve that topsoil, it becomes a desert, which does not promote plant growth anymore. If the topsoil goes away, several things can happen. Erosion can start to happen. Another thing that can be degrading to soil is also salinization, or the buildup of salt in the soil, and then compaction, or the literal compacting of the soil by either people or animals walking on it, or large construction equipment, or roads, or buildings. As you can see, soil degradation is a global issue. It's not just something that's just happening around here. So for the most part, Florida's doing okay, but a lot of areas in the U.S. have severe soil degradation problems. Degraded dry land ecosystems can put put people at risk, not only just health risk, but also economic risk as well if people depend on crops for to make their money. This was taken in Vietnam at a once fertile but no longer fertile site. This site is a result of what we call salinization. So if you irrigate soils over and over and over and over again from artificial irrigation, salt can build up in the soil over time from wherever you're getting the irrigated water from. And after a while, if the salt builds up too much, then it will destroy the ability of the soil to grow plants. Mm, There's mining. When we mine ores and metals. Ores are concentrated accumulations of minerals, which are economically valuable, and metals are elements that can conduct electricity and perform other important functions such as copper, nickel, and aluminum. And if you look over here, you can see what metals we have, how much, if we consume them at the current rate, how much we have left and how much we have in the U.S. And as you can see, a lot of the metals we don't have in the U.S. we have to import from other countries. Different types of mining. We have surface mining. A couple types of surface mining. We have strip mining, which is the removal of strips of soil and rock to expose ore. The leftovers are called mining spoils or mining tailings. And a lot of times these mining spoils or mining tailings can carry various pollutants in it, and we'll talk more about that later. Additionally, we have another type of surface mining called open pit mining. It's the creation of one large pit in the ground that is visible from the Earth's surface, and it's used when the resource is pretty close to the ground. Copper mines are usually open pit mines. Another type of surface mining is mountaintop removal, where the miners remove entire tops of mountain with explosives to expose the ore. And then there's placer mining, which is also, if you've like panned for gold, this is placer mining. It's the process of looking at metals and precious stones in river sediments. Last type of mining is called subsurface mining. It begins with a horizontal tunnel dug on the side of a mountain. And coal, diamonds, and gold are some of the resources removed by subsurface mining. You look at this chart in your book. It tells you the major effects of surface mining on air, water, soil, biodiversity, and humans. It would be good to know this for the quiz on Friday. And last but not least, a couple of laws that have to do with mining. There's the Mining Law of 1872, which seeks to promote a settlement and development of out west for people to mine certain ores such as gold, silver, and copper, and fuels such as natural gas and oil. And the second big mining law is the Surface Mining Control and Reclamation Act, which says that mines must reclaim or put back into a natural state open pit mines or subsurface mines after mining for coal. Good luck studying. Please let me know if you have any questions. See you later. Bye.